the last lecture, we were discussing about fuzzy relations and the operations on fuzzy relations, right? So what operations did we study in the last lecture? Do you recollect? On fuzzy relations, what kind of operations we studied?
Union,
intersection,
Intersection,
complement,
projection, cylindrical extension,
cylindrical extension, yes, and projection. Okay, properties and operations. And we also talked about fuzzy composition. Do you recollect? Fuzzy composition. What are the two types of composition methods?
Max min and max product.
Very good. Max min and max product. What is the criteria for performing fuzzy composition? For the two relations. If there are two relations R and S, what is the criteria for performing composition? If R is X cross Y, then S has to be Y cross Z. This has to be common, right? Then only you can perform composition. So that is the criteria for performing composition. What about projection and cylindrical extension? Projection, what does it do? What does a projection operation do? When you have given a fuzzy relation R, what does it do? If it is binary, in the fuzzy relation R is a binary relation.
It makes it a fuzzy set.
So projection is used to actually reduce the dimensions, right? Reduce the dimensionality of a relation. So if it's a ternary, it will make it binary. If it is a binary relation, it will make it a fuzzy set. If it is a fuzzy set, it will become crisp set. Okay, so that is the projection operation. And what about cylindrical extension?
It's the reverse. It increases
It's the
one dimension.
opposite. Exactly. So if you have one fuzzy set, 1D fuzzy set, you can actually convert it into a 2D fuzzy set, 2D relation. Okay, that is cylindrical extension. So these two operations, don't forget, and composition, the condition, don't forget. Okay, so these are the kind of operations that you can perform on fuzzy relations. Now, just want to move a bit ahead and talk about a new concept, that is a fuzzy knowledge based system. Okay, fuzzy knowledge based system comprises of different components in its architecture, because that is going to actually solve a problem. A fuzzy knowledge based system is going to solve a problem. So you're going to apply this architecture to solve a problem based on fuzzy set theory. So different components are part of a fuzzy knowledge based system, and uh, we'll be seeing one such component today, that is defuzzification. So first of all, let us talk about what a fuzzy knowledge based system is, and then we'll talk about defuzzification. So this is the block diagram of a fuzzy knowledge based system. So looks, so you'll see a series of blocks, okay, and a flow from left to right. So left, you have starting from here, going here, and then you have the output. So this on the left hand side of it is the input part when you're taking the input. So whatever is the input, that it's going to go inside this fuzzy knowledge based system, and then there'll be certain blocks which will be applied, certain operations which will be applied over the input. Okay, and then you will finally get the output. So a fuzzy knowledge based system actually has different steps on the basis of which a problem is solved using fuzzy set theory. Okay, so this fuzzy knowledge based system starts with taking input in the universe of that problem that you are going to solve. Okay, so let it be used for solving any kind of a problem. A very traditional application is a controller based application. So for example, washing machine or air conditioner. Okay, so whatever actually it's going to go into the system is going to be some input which is required for the correct functioning of that controller. Okay, so for example, for the washing machine, it will be, there'll be some sensors to detect the dirt, the grease which is attached to the clothes. Okay, so that is the input that will go into the system. So first is the crisp values of the inputs are given to the system. Okay, and there is a first block that comes in, that is a normalization block. So the crisp value from that domain, real world domain, is accepted by the system. It's given to the system. And then there is a scaling transformation which is used, which maps the physical domain to a normalized universe. So from that, there is some kind of a normalization which is done, because see, the values will be in some real world values. So you need to bring it down to some scale. There is some scale transformation which will map the physical domain to the normalized domain. Now it depends how it is done. So whether it is done in terms of percentage, you can do it in terms of percentage, because there will be actual values which the sensor will sense, right, in terms of some units. Those units you can, I mean, those values you can keep them as they are, or you can normalize it. Usually they are normalized for solving problems at the real world level. So you apply a normalization which will actually bring it everything into the same. So if there's a generic controller that you're building, so any particular problem that you're trying to solve, it will normalize it to on certain scale. Okay, so that is the first step. After that is done, you have the next step, that is the fuzzification step. So after the normalization is done, you apply the fuzzification step. Okay, and what does this fuzzification do? It converts a crisp input to a fuzzy set. You know already what fuzzification does. So whatever the value is, now what you need to do is you need to convert that value, or you need to map that value into a fuzzy set. Okay, so how do you do it? How do you do it? You decide some certain things, right, with respect to fuzzification. So if you're talking about fuzzification, you need to talk in terms of linguistic variables, right? So you have certain linguistic variables which are defined with you, which will help you in fuzzifying. So whatever the value comes into the system after normalization given to fuzzification module, it will convert that crisp input to a fuzzy set. Next, what is the next step? So next step is defuzzification. But before that, let us see what is there in between. Okay, in between, in between there is something called as an inference engine. Okay, and there are two databases. One is a database, one is a rule base, which is attached at the central portion of this fuzzy knowledge base system. So there's a database and there's a rule base. So what does this database consist of? So database actually consists of this fuzzy MFs, the fuzzy membership functions for the input and the output. Okay, and the physical whatever is everything, whatever we were talking about so far, everything it is actually going to get from the database. So there's a database which is associated, which is actually storing the fuzzy MFs, the physical domain values, the normalized values, the scaling factors, everything goes into the database. That is, all the data related to the problem is actually saved in the database. Plus, the fuzzy membership functions are also saved. Whatever the fuzzy membership functions are for the input and for the output, they are also saved in the database. Next is the rule base. Now, what is this rule base? Rule base is a set of fuzzy if-then rules. Okay, or it is a list of fuzzy if-then rules. So, in case of Boolean logic, you know that you can express these implications, right? If-then rules. In terms of implications, you can make some rules. If you have modeled some problem using Boolean logic, so if you're going to solve, so you have if-then rules there. If else, if this is true, then I will do this. If something else is true, I will do that, right? So if-then rules are present in case of Boolean logic. Similarly, if-then rules are present in case of fuzzy logic, but they use fuzzy logic. So it's not, you know, that if-then rules, they comprise of two parts, the if part and the then part. The if part is the precedent, and the then part is the consequent, right? So based on the precedent, the truth value of the precedence, the then part will be done or will be executed based on the truth value. In case of Boolean logic, either the if part will be either true or false. But in case of fuzzy logic, there will be a truth value associated with the if part. That value will be between 0 to 1, right? So again, in the then part, there will be some value, truth value between 0 and 1. So in both the if part as well as the then part, there will be a value between 0 and 1. So later on, we'll look at fuzzy if-then rules as well. So don't worry about that. We'll come to that, how it works. But just to give you an analogy, it's similar to that. Only thing is there's a degree of membership in the if part as well as the then part. Okay. Next is the inference engine. The inference engine actually comprises of finding or what we should do, what the system should do, actually inferring on the basis of certain facts which are there. Okay, facts and rules, the rules which are there. On the basis of these rules, the inference engine is actually going to infer and compute the overall output. So what it's going to do is, you will have, depending on the input, you have got what you have got so far is just the input, and you have now the fuzzy input with you, right? So that comes in the if part. Now based on that value, whether it is 0.8 or 0.7 or whatever, it is possible that multiple such rules will be fired. Multiple such rules will be fired. So the degree of match of each rule will be used to infer the overall output. Okay, so you will use the inference engine is actually going to use all these rules, find out based on the input what is the degree of match for each rules. So suppose there are 100 rules in the rule base. So out of that, say 5 rules are matching depending on the value of the input. So each rule will map to some extent. So say rule 1 is mapping to some 0.7. Rule 3 is mapping to 0.5 and so on, something like that. Okay. So based on that, this match, degree of match, some overall output is computed using some technique that also we'll be seeing. So that is the role of the inference engine. Okay. So which rule should we consider? Whether we should consider rule 1 or rule 3 or whatever. Or if it's a combination, it's a combination usually. It's a combination. It's an aggregation of all the rules. So if you consider the aggregation or combination of all the rules, then what is the overall output that you need to look at so that you find out the final output, the actual output of the controller, of the system. Okay. So then once this inference engine is used, then you do a defuzzification, because whatever output you have got is still in the fuzzy set, is still a fuzzy set, right? Whatever output you have got is still a fuzzy set, because all these are fuzzy rules. So in the then part also you have some degree of match. So some 0.7 or whatever, 0.85, whatever. Now again, and for every rule you will have, and then you are combining. So defuzzification basically is nothing but it is actually going to convert the overall output into a single crisp value. So whatever the output you're getting, the combined output that you're getting after doing the inferencing, you need to actually convert that back to a single crisp value. Why a single crisp value? So for example, in case of a washing machine, you need to find out how much time is required to wash the clothes. So the output that is required is a prediction that the machine needs to make is basically the wash time. Okay. So you need to actually convert this fuzzy set that you're getting in the output to a single crisp value, right? Which should be as per the input that is given. That is the dirt or grease, whatever inputs that you're considering in the washing machine domain, problem domain. And then of course you have to, once you defuzzify, it will be since you had scaled it to some scale, so you need to apply a denormalization block, and then you get it back to the original crisp values in that domain, in the original domain. So it depends. If you are normalizing, then you have to denormalize. If you are not normalizing, so it is not compulsory that you normalize everything. Okay. It depends. If the controller can be used for a multiple set of systems, then in that case you might need to perform normalization. Okay, that's a generic controller. But if you're not applying normalization, then you do not need to denormalize it. That's very natural, right? So these are the set of steps that you need to follow, okay, so that you solve a problem using a fuzzy knowledge-based system. So it's called a knowledge-based system because it has this inherent knowledge base, which is comprising of the database of all the values, the fuzzy sets, the conversion factors, plus a set of rules. Okay, so it's a knowledge-based system, and the inference mechanism that is done, that is on these rules only, and the data that is currently given to it. So that is why it's called as a knowledge-based system. So this is the architecture of a fuzzy knowledge-based system. Okay. So for an AC, so let us consider we are applying this architecture to design a fuzzy knowledge-based system for an AC, air conditioner. How will we do it? So first of all, we need to decide what are the set of inputs, the outputs, right? Whenever you're modeling a system, you decide what's going to go as input to the system and what is the expected output. Okay. So let us consider that the inputs that I'm taking is the current room temperature and the humidity level that is there. Okay, those could be the inputs. So there'll be some sensors which will sense the inputs. Okay, so So how will you characterize it? So if I say my inputs are temperature and humidity levels, right? What are you going to do? You are going to decide what will be the linguistic variables. As a designer of the system, you are going to decide what will be the linguistic variables which will define these fuzzy sets. Okay. So whenever you're saying temperature, you need to decide different ranges based on which you will write the rules later on. So the rules will be somewhat like this. What will be the rule? Rule will have input as well as output. So first of all, let us decide the inputs, outputs. Then we'll talk about rules. So what these are the inputs. What will be the linguistic variables for temperature? You will have to decide the ranges like hot, medium, cold, something like that. Or you can have a finer gradation. So you can have two, right? Too cold, cold, warm, hot, something like that. Too hot. Okay. So these could be my linguistic variables. I'm so sorry. These are the linguistic variables. These are the values. These are the values, linguistic values. Yeah. So temperature and humidity are the linguistic variables. These are the linguistic values, right? So next is humidity. What about humidity? What could be the linguistic values for humidity? Say it is dry. I can say that the room that I'm in, where the AC is going to work, it's dry. Okay. I can use different, I say it is refreshing, or I can use some different terminology here. I can say it is comfortable. Okay. And I can say it is humid. And then I can say it's too humid or it is sticky. Okay. So these are the inputs, input variables and the input values, the values. Right. Next, what you need to do is the outputs. What will be the outputs for this AC? The outputs for the AC, I mean, there could be several such outputs. The outputs, actually, what you need to do is you need to control the room temperature, right? Okay. But that room temperature will be controlled. So depending on whether the temperature is hot. So if the temperature is hot and it's humid, right? Humidity is humid. Then I need to do certain things in my AC such that the temperature is at par with what should be comfortable for the user. Okay. So then what I can do is there are different ways of designing the system. I can either decide that, okay, I need to reduce the temperature of the room. So how do I decide to reduce the temperature of the room? Using the AC, what does the AC have to reduce the temperature of the room? So there's a fan, right, in the AC. And there's a compressor. So the compressor speed can be controlled. The compressor speed can be controlled. The fan speed can be controlled. Okay. So then you can consider this compressor speed and the fan speed as the outputs of the system, because these are going to in turn control the temperature of the. Okay. So temperature is hot and humidity is humid. Then the compressor speed. So let us write the outputs. The compressor speed, the compressor speed. The compressor could be off. It could be very low speed, medium, or fast. So this is up to you how you write these things. See, I'm just giving you some example. So you can, I mean, just logically you can write these things, these values of the variables, the linguistic variables, right? Then the fan speed. On similar lines, can you tell me what the fan speed could be? The same thing, right? Of very low, medium, and fast. What else? Another output could be the operation mode. You know, there are operation modes, cool hai, dry hai. These modes are there with the AC. Cool mode, right? So that could be another output. So it depends on the AC actually. What are the features and what all is going to control the temperature. So operation mode could be one more output. So operation mode is there. So again, it will have some linguistic values. So cool and dry. Okay. So these are the inputs, these are the outputs. I have defined the linguistic variables, right? And the values also. So in fact, these linguistic values, actually, these are going to be the fuzzy sets in my system. For each input, each of the inputs and each of the outputs, I'll have these fuzzy sets defined. So I don't just define it directly. I need to have a knowledge, the proper knowledge of the system. That means I need to have a domain expert with me. So what is the ranges of the temperature possible, right? Temperature of a room, what are the ranges that I'm going to look at? Range of values that I'm going to look at. Then what are the humidity values? Right? Whatever speeds I'm talking about, what is the unit on all that? So I need the domain expert or some expertise. I myself need to have an expertise, or I need to consult a domain expert for designing this. Okay. Once I decide this, I decide the ranges and all that. Next step will be to decide a set of rules. So you will have all this data is there with you, everything is there, you have modeled everything. How will you model using fuzzy sets? You will use the fuzzy membership functions, because all these values which are there, there'll be a range, right? So temperature is 0 degrees, or it could be minus also, it depends on the region. Okay, to say 50 degrees or 55 degrees, whatever, yeah, Celsius, something like that temperature. So this is the temperature I'm considering. I need to make fuzzy sets. So what will I do? I will use the standard membership functions. I will make use of standard membership functions which I have studied. You recollect? What are the standard membership functions?
Triangular, trapezoidal.
Yes, exactly. These functions you will be using to, have these temperature ranges, humidity ranges throughout. And then what you will do after this, you will devise a set of rules. So you will form your rule base. So rule base will be depending on, intelligently you need to control the temperature of the room. So based on the combination of inputs, multiple inputs, what the output should be. So what could be a sample rule here? Can someone tell me a sample rule? So rule will be written in terms of linguistic values, variables and their values. So if the temperature is dash, can now someone tell me one rule, sample rule?
If temperature is cold, then the fan speed should be low.
If temperature is
Too cold.
cold,
Cold. Then
okay.
fan speed should be low. Operation mode nahi.
Humidity.
Humidity. Okay. All
So if
inputs
you
are
want to
compulsory.
combine inputs, you make use of AND. Okay. when you're looking at the effect of both inputs. So usually you use the AND operation, but sometimes it could be an OR. So it depends. The rules could have an AND, they could have an OR. What is the difference? If you're using AND, that means you are looking at the combined effect of both inputs. If you're using OR, that means either one. If either this is there or this is there, then I do that. Okay, whatever. Then I do blah, blah, blah. So when I combine multiple input variables or output variables, then in that case, I can use either AND or OR. Okay. In general, you will see whatever problems which are solved, most of the problems they use AND. They look at the combined effect. But there could be some cases where you need to look at individual effects as well. So then you can take single inputs as well. Okay. So in that case, it is not going to, the second parameter is not going to influence at all. Okay. So I'm just giving you a generic rule. So humidity is dry. Then I need to talk about what will be each of these outputs: compressor speed, fan speed, operation mode. Okay. So again, this could be any one, all three, any two. Okay. But when you're writing rules, whenever you're writing rules, you have to be having that knowledge of, domain knowledge. So then only you'll be able to devise correct rules for that particular scenario. Otherwise, there can be so many rules. If you consider all possible combinations, that is not required. You do not require all possible combinations. Okay. So when you're talking about all possible combinations, so you will have in terms of inputs. Okay. So when we are using AND, then usually what we do is we create a matrix like this. So two inputs, most of the problems we have two inputs, but there could be three. If there are three, you cannot put it in terms of a matrix. You'll have to write them in this fashion. Okay. So what we do is at one row wise, you put some input, column wise, you put some input. So if you consider all possible combination, the maximum possible rules, if you're using AND, you're using the AND operator, then you will have 25 such rules. Right? Because you have 5 here and 5 here. Okay. But if you have a combination of rules, AND hai, usme or hai, usme koi single hai, then you cannot be very sure of how many rules you will have. Okay. So it all depends a lot on the expertise of the system that you're modeling. Okay. And you'll have to see, when you're actually looking at it, now you're talking in terms of only fuzzy variables and values. You're not talking in terms of actual values. So you require the actual knowledge of the system, because you need to know the physical domain also, what is going to happen. Finally, temperature, what will be predicted? Will it be like very wrong? If I write these rules, so the rules have to be correct for a system to work. The rules that you're framing have to be correct. Otherwise, it will go haywire. Okay. So rules form a very important part of modeling a fuzzy inference system. It's also called as a fuzzy inference system. Fuzzy knowledge-based system is also called as a fuzzy inference system, FIS. Okay. So this is how you're going to do it. So compressor speed is whatever. Cold and dry. Compressor is speed is very low. Fan is off, something like that. Okay. And operation mode is whatever, cool, or it is not required. So this is one example of a rule. There'll be n such rules. Are you getting it? So it's very difficult when you talk about a real world scenario. Now you have to look in terms of all aspects and you have to carefully design the rules. Okay, and then what you do is once your rules are done, what will be the next step? As if you try to visualize the block diagram, what will be the next step? After
Inference.
your inference is done, so you are getting actual value ना, तो ये अभी cold and humidity. ये rule directly, this is one of the rules. Several such rules might fire depending on what is the current detected values of temperature and humidity. Remember, sensor values will be in the physical domain range, so it will be some value which you will get, na, crisp input which you will get. So say temperature of the room is, you have said it is cold. Okay, so let's say it is 13 degrees. Sensor detected 13 degrees. Okay, and humidity some in terms of some value range. Okay, some value, it will be a crisp value. So then based on this value you will map it to the corresponding fuzzy set. Okay, so fuzzy set will be what now? It will be cold, it could be, it will lie to a certain extent in too cold also. Why? Because when I draw this one, this temperature, when I plot it, draw this on a plot. So what will be too cold? Suppose it's starting from 0. Just assume it is starting from 0. It could be negative also. Okay, so too cold is this, right? Something like this. And then cold. Okay, then warm. Too cold. Something like this, now you will get this one. Hot and then too hot. So there will be some overlap. So when you're saying temperature is 13 degrees Celsius, 13, this value, suppose this is 13. 13 will have a membership in very cold as well as cold. So there will be multiple rules which will fire wherever the antecedent is containing temperature is cold and temperature is very cold. Those rules will be fired, right? Are you getting it? Similarly for humidity also. Those many rules will be fired, and each rule will be fired to a certain extent. And what is that extent? The membership value. 13 की membership value very cold में क्या है? What is the value, membership value of 13 in cold? It will be different, right? So that is the degree of firing of the. Okay. And then what you will do is you will find out the output, what the output should be. So for that there are certain methods, certain techniques which you have to apply. Okay, I'll talk about them also when we talk about the complete inference. Okay, and then you will get some fuzzy output, because output right hand side is also fuzzy only. So you get fuzzy output. Now what you need to do is you need to actually convert this fuzzy output to a crisp value. And for that purpose, you require what is known as defuzzification. So defuzzification is going to convert this fuzzy output into a crisp value. So there's a region a probable region where the output is expected. That region in this area. So there will be some, suppose we are talking about in terms of compressor speed. So compressor speed also has all this, right? Something like this, all this, right? So maybe this much is the region. Only this much is the region where the output is expected. Okay, this much. So that will be the output actually of the inference engine. And from this inference, this output that you have got, you need to find out which is the actual value. Okay, so the actual value will be on this axis, the x value, x-axis, right? This value. And there are different ways of finding that out. So how do you convert a fuzzy set back to a crisp value? That is defuzzification, and there are different defuzzification techniques. And finally, using one of these defuzzification techniques, you will get the output for that system. Okay, so this is the entire process of the fuzzy knowledge base controller. Okay, hope you have understood this. The roughly how actually it works, the flow. Yes.
Yes, ma'am.
So we have about 5 minutes. So let me just tell you. So defuzzification is the process of converting a fuzzy set into a crisp value. And there are several such types of defuzzification techniques or methods. These are the set of methods. So we'll have to look at these one by one. And there is a mathematical formula for each of these. Okay. And there are certain cases where you require to use these, where you can use this, where you cannot use this. So for certain regions that you are getting as output region that you're getting, the aggregated output you're getting, you can apply. So for example, some of these defuzzification methods cannot be applied to non-convex regions. Okay. Some of these can be applied to only convex regions, some of these methods. So those we have to look at carefully. Some are versatile, some can be applied to everyone, to all possible regions. And that is why they are used in practice. Okay, some of these are having some kind of bias towards certain areas on the plot, on the defuzzification output region. Okay. So that they are not ideal to use, although the calculation is much faster. So it depends on how much time you need to calculate the value. Okay. So these are used depending on what kind of all these parameters that I mentioned, that is what kind of accuracy you want, what kind of output region you have, whether it is convex or non-convex. Okay. How complex it is to perform this particular defuzzification. So on that basis, one of these methods is chosen. Okay. And when you look at papers which actually have these fuzzy set or fuzzy controllers, you will find a comparison of different defuzzification methods which authors have employed in the system, and then finally choosing one. Okay, so that is on these factors. So this is about the types of defuzzification. We will discuss each of these one by one, and then we will solve problems in the next lecture. Okay.
Ma'am,
Yes.
ma'am, in the experiment which we are supposed to do, the PS2, usme in the doc
Yes.
you have given